Hi everyone, my name is Vatsala Nundloll. I'm originally from Mauritius. I have a background in computer science and have done both my master's and PhD at Lancaster University. And now I have been working as a postdoctoral researcher here at Lancaster University for the past 8 years. I have worked on diverse research projects, ranging from data mining, social media websites, to look for patients for clinical trials for a pharmaceutical company, through the design and setting up of an IoT sensor infrastructure in North Wales to monitor the environment, to designing ontological models to better understand how systems work, to finally being part of this cross-disciplinary project from its start. I have been involved in the flood, biodiversity, soil, and now the ecosystem sprints. In the flood sprint, I devised a framework to integrate disparate data sets together and to query information from a multi-source data model. I worked closely with flood scientists from JBA who mentioned that there was some useful flood information found in government reports. These reports are known as Section 19 reports and contain information such as emergency responses for flood-prone locations. Whilst the flood scientists used observed data about rivers and gauges stored in Excel spreadsheets for analysis, they would also like to get more information about these rivers and gauges. For example, enrich their information quest with the information found in the government reports. This was a challenging task, but I found that using natural language processing techniques, it was possible to extract information from an unstructured source like the PDF report and bring this together with more structured information residing in the Excel sheets through the use of semantic web technologies. This unified model enabled to make richer queries around a flood-prone location and provided better insight in terms of flood risk assessment. This work was taken further through a knowledge transfer partnership program, and I was happy to assist Will Claydon, who was hired on the project to continue the flood work further. Although we've collaborated entirely virtually, we've had a good interaction, and we're also talking about our experience in one of the Fred's talks. In the biodiversity sprint, I have explored how to extract floristic information from a historical journal, a botany journal dating back to 1885, which contains a lot of information about plant species found in the Lake District. I used a nice annotation tool called Prodigy to annotate relevant pieces of information from the journal text, like plant names, names of people who observed those plants, the locations in Lake District where they were found, and some other additional information, like, for example, if a plant was found by a riverbank or the side of a mountain. The beauty of this work was that the information residing in a very old journal was extracted and made queryable using digital technologies. This information was also enriched with other information such as plant taxonomy, coordinates of locations, so as to make information-rich queries. In the soil sprint, some soil scientists provided us some data regarding a soil experiment which measured soil greenhouse gas flux from different plots of soil where different fertilizers had been applied. This work started during the first lockdown, and we're working from home. I produced 2 strands of work with this data set. First, I did data visualization of the soil data for an exploratory analysis. I used different kinds of plots, and looking at the plots, we could simply tell a story about these different gases that were measured. For example, the time of day when there was a maximum carbon dioxide gas flux. These plots could also tell if there were any correlation between different soil variables. I also did some predictions on the data using time series forecasting models. Although the data provided was quite small, but it was fascinating to learn. And the work drove me to the conclusion that no matter how good a machine learning model you may use, we also need to ensure a higher fidelity in the data. For the ecosystem sprint, in this current sprint, I've designed an ecosystems model to show how every different aspect of an ecosystem is interlinked with other aspects of the ecosystem. And this is found on the website of the Ensemble project. And I also worked in collaboration with Harriet, an artist with whom I have done a thread talk. Harriet carried out a survey to collect the views of people about Lake District, and I did a visualization of the textual data that she had gathered through her survey. The visuals showed a beautiful word cloud with different terms used by people that were demarcated on a graph based on 2 age categories, like above 44 and within an age range 20 to 44. We also worked with an intern who created some computer-generated poetry based on these word clouds. This collaborative work was presented by Harriet in an online exhibition that she organized during the lockdown. I will say that data plays a big role in getting a better understanding of our surrounding and environment. When we talked about data a few years back, we would simply think of a big table of numbers, but this perception is changing now. Data is in form of text, imagery, sound. And with the advances made in AI, mobile technologies, and social media platforms, these new forms of data are becoming more prevalent in different domains. With such a plethora of data available, we can already see the popularity of cloud computing platforms. We will also see data integration platforms taking prominence to bring all this information together. This does not relate to environmental sciences only, but any other area, as data lies at the heart of everything. Thank you for your attention.